Hello everyone. In last lecture, we have seen the method to find IF to, to make given equation exact. Okay. So these are the four methods we have seen. If equation is homogeneous equation with mx plus ny is not equal to 0, then 1 upon mx plus ny is the integrating factor. Secondly, if the function is of the form f1xy into y dx plus f2xy into x dy is equal to 0. That means some function of x into y dx plus some another function of x into y into x dy is equal to 0, where mx minus ny is non-zero. Then 1 upon mx minus ny is integrating factor. Third case we have learned is 1 upon m del n by del x minus del m by del y is a function of y only, say f of y. Then e raised to integration fy dy is integrating factor. And the fourth case is 1 upon n del m by del y minus del n by del x is a function of x only, say fx. Then e raised to integration fx is the integrating factor. And this example we have solved last time for homogeneous one. Today we are starting with a case to solve the differential equation x square y square plus 2 into y dx plus 2 minus x square y square into x dy. So here the given equation is of the form f1xy into y dx plus f2xy into x dy equal to 0, because see, this is a xy the whole square plus 2. This is 2 minus xy the whole square. That means function of xy into y dx plus some another function of xy into x dy. Correct? So what we are going to do is, here m is your x square y square plus 2 into y, and n is your 2 minus x square y square into x. Now for this case you have to multiply m with x, n with y, and subtraction you have to find out. So mx minus ny is equal to x square y square plus 2 into xy minus 2 minus x square y square into xy. So multiplying this inside and simplifying, that will give you x cube y cube plus 2xy minus 2xy plus x cube y cube. 2xy will be cancelled out and we will have 2x cube y cube, and therefore our integrating factor is 1 upon mx minus ny, that will be 1 upon 2x cube into y cube. Now once we have the integrating factor, then we have to multiply the original equation by if. So multiplying the equation 1 by if, so multiplying this equation by if, that will give you x square y cube upon 2x cube y cube plus 2y upon 2x cube y cube. What I have done is I have multiplied this y inside and then multiplying each term by 1 upon 2x cube y cube plus 2y, that means you have this equation x square y cube upon 2x cube y cube plus 2y upon 2x cube y cube dx plus 2x upon 2x cube y cube minus x cube y square upon 2x cube y cube dy is equal to 0. So simplifying this term, that will give 1 upon 2x plus 1 upon x cube y square dx plus 1 upon x square y cube minus 1 upon 2y dy is equal to 0. Now this equation 2 is the exact. If you have to check, then you can check it. Find out the derivative of this term m with respect to y. so this will be 0, and derivative of 1 upon y square will be minus 2 upon y cube into x, so that will be minus 2 upon x cube y cube. Same manner here, derivative of x, so 1 upon x square as integration derivative minus 2 upon x cube. So this two term derivative will be same, and this equation is reducing in a form of xz. So equation 2 is xz. So the m dash is equal to 1 upon 2x plus 1 upon x cube y square, and n dash is equal to 1 upon x square y cube minus 1 upon 2y. So these are the two equations we have, and now the general solution is given by integration m dash dx, where y is treating as a constant, plus integration n dash dy is equal to c. So integration of m dash is 1 upon 2x plus 1 upon x cube y square dx, plus integration n dash, where you have to write down the terms free from x. So the terms free from x are only minus 1 upon 2y, because here you have the term of x. So now integrating, so first term integration of first term with respect to x, that is log x cube, 1 upon x cube, that is x raised to minus 3, has an integration x raised to minus 2 upon minus 2. Simplifying that term, that will give you minus 1 upon 2x square y square, and 1 upon y has an integration log y. So each term has a 1 by 2, 1 by 2. So multiplying by 2, that will give you log x minus 1 upon x square y square minus log y is equal to 2c. We are going to say is equal to c dash, and therefore log of x by y minus 1 upon x square y square is equal to c dash. Same manner we are going to check out now case 3. Now see, here solve x square plus y square plus 3 dx minus 2xy dy is equal to 0. See, this equation is neither homogeneous nor it is a function of x into y, because this term is not a function of x into y. Oh, correct. So what we are going to do, first we are going to check out whether it is a xz or not. So m is equal to x square plus y square plus 3, n is equal to minus 2xy. Derivative of m with respect to y, that is 2y. Derivative of n with respect to x, that is minus 2x. So plus and minus sign is there. So difference we have, that means it is not exact. Now it is not exact, as well as it is not homogeneous, as well as it is not a function of xy. So case 1 and 2 is not applicable. Now we are going on to case 3. Now case 3 or case 4. First I am going to check out case 4, as we have this is n is equal to minus 2xy. So I am starting with 1 upon n del m by del y minus del n by del x. I have told you, if we are dividing by n, then the second term will be of n and first term will be of m. So del m by del y is 2y minus plus del n by del x will be 2y. So 4y upon minus 2xy, and simplifying this term, that will give you minus 2 upon x. See, this is the function of x only, and if it is a function of x only, then you can apply the case 4. So here it is a function of x only, so I am going to write down this is equal to fx. So integrating factor will be e raised to integration fx dx, that is e raised to integration minus 2 by x dx, and 2 by x as the integration minus 2 log x. So simplifying this, minus 2 will be in the power of x, and e raised to log will be cancelled out, that will give you x raised to minus 2. That means 1 upon x square. Multiplying equation 1 by if, and that will give you 1 plus y square upon x square plus 3 upon x square dx minus 2y upon x dy is equal to 0. So m dash will be 1 plus y square by x square plus 3 upon x square, and n dash is equal to minus 2y by x, and therefore your general solution will be integration m dash dx plus integration n dash terms free from x dy is equal to c. So m dash is 1 plus y square upon x square plus 3 upon x square dx plus 0 dy is equal to c. So see, what we have to do is integration of this term with respect to x. So here it is 1 as integration x, 1 upon x square has an integration minus 1 upon x. Here also minus 1 upon x is equal to c. And taking LCM, that will give x square minus y square minus 3 upon x is equal to c. So this is your general solution. The same thing we are going to apply for the case 4. Same thing we are going to apply for case 4, but case 3. So solve e raised to x plus y into e raised to y dx plus x e raised to y minus 1 dy is equal to 0. Here m is equal to e raised to x plus y e raised to y. N is equal to x e raised to y minus 1. So here I am going to differentiate m with respect to y. So e raised to x plus y has a derivative e raised to x plus y. But y into e raised to y has a derivative by multiplication rule. So y as it is, derivative of e raised to y is e raised to y plus e raised to y as it is, derivative of y is 1. And here derivative of this term with respect to x, that will be e raised to y. So these two are not same, so it is not exact. Now what we are going to do is we are going to apply case 4. See, this case 3 and case 4 are trial and error. So first you have to try case. I know which case is applicable, that's why I have directly written. But you have to start with trial and error. You have to first apply case 3, then you have to apply case 4. So here I have started with case 3. 1 upon m into del n by del x minus del m by del y. So 1 upon m is e raised to x plus y into e raised to y. And del m by del y is e raised to y minus del n by del x is e raised to y minus del n by del y is e raised to x minus y e raised to y minus e raised to y. So e raised to y will be cancelled out. Now see, here you have minus e raised to x plus y minus y e raised to y. If you are going to common out minus, then these both terms are same and they will be cancelled out. So the answer will be minus 1. Now minus 1, you can consider the constant as a function of y. So it is a function of y, and therefore the integrating factor will be e raised to integration fy dy. So e raised to integration minus 1 dy, that will be e raised to minus 1. So multiplying equation 1 by if. So that means you are going to multiply this equation by e raised to minus y. So e raised to minus y plus y can cancel out. Here also e raised to minus y plus y cancel out. Here also e raised to minus y plus y cancel out. And here we have e raised to minus y. So the equation will be of the form e raised to x plus y dx plus x minus e raised to minus y dy is equal to 0. Now m is equal to e raised to x plus y and n is equal to x minus e raised to minus y. So instead of m and n, now we are going to write m dash and n dash, as already m and l we have already defined. So the general solution is given by integration m dash dx plus integration n dash terms free from x dy is equal to c. So integration m dash, that is integration e raised to x plus y dx plus integration term free from x, that means minus e raised to minus y. So integration minus e raised to minus y dy is equal to c. Now integration of e raised to x is e raised to x. Integration of y with respect to x, that will be x into y. And e raised to minus y has an integration e raised to minus y upon minus 1. So minus minus plus. So that will be e raised to minus y is equal to c. So the answer is e raised to x plus xy plus e raised to minus y is equal to c. So what we have done is we have checked all the cases. See, first and second case is you can check it by simply by seeing whatever the equation given to us, whether it is homogeneous or it is the function of xy, and then if they are not, then you are going to check it for case 3 and case 4. But before going on to that, first you have to check the exactness. If they are not exact, then only you are going to define this, otherwise it is not necessary if it is exact. Okay.